Mengenai itu anti itu di PO ini jadi latihan yang ada boleh itu kan mengalir. Hari itu mengenai anti mereka kena ini. Karena proses ini hari high ball sulit kan. Ya lain. Alright. Ini versus Burak memang view itu dikit mata ini the same level liquid field. Same cross section area. That's all the liquid, but the bottom of the surface having the less area. That's it. Right. Area is it. So then liquid is filled there. Okay, liquid filled there. Then remember that forces acted on the cylindrical one. Forces acted on these walls. Right, they are equal and opposite at which level. This is let's say the R and R. So they cancel. So then there is no resultant force horizontal. Horizontal resultant force is zero. But bottom of the surface, right? So let's say its force is F1. So the F1 is downward, you can consider it as the pressure, hydrostatic pressure multiplied by this cross-section area. If this cross-section area, that's the hydrostatic, let's say this is all the vessels, they're having the same height of liquid, or depth of liquid is h. So this density is rho, right? So then you consider h rho g a. So here the force A equals to AH rho g. That is the force applied on this bottom surface of the vessel, right? So you can remember this AH means the volume inside this vessel, right? And rho is the density of it. So then it's a mass of the volume included in this vessel. So then mg here this is equals to mg. In this scenario, there are no forces acted on the side walls, but the force on the bottom is equals to the weight of the liquid inside it, right? And then come to the second one. Here that's also having the same height, liquid, same bottom surface area is same as the previous one. But here you can see, am I drawing a dotted line there? So this dotted line represents the previous cylindrical vessel, right? So that volume. Here that volume is little greater than the volume of this vessel. Is now it means you that the volume inside that's the mass or the weight of the liquid inside the vessel is then now it's greater than the previous one. So we apply the force apply on the bottom, let's say it is F1. Similarly, we can write it is equals to the that's AH rho G because H rho G is the hydrostatic pressure and the A is the area. Clear? And then there's other forces acted on this side. I'm drawing in the different color. Let's see. There's a force acted on this wall perpendicular to it line. Right. And here also force perpendicular to this wall. And then this one has a components that's downward component and a horizontal component. Right. Arrow එකම දාලා මේන චුට්ටක්. The wall has the perpendicular force on it like this. So their components, I'll draw the components in different color. Right. So the component is in vertical component is there, it's vertically downward. It's acted on the right. And the horizontal component is also there. This pink color one are the component of these forces acted on this side, right? And you can see here also then this horizontal component at the same level, same pressure applied. So then they are equal and opposite, they cancel out, right? But the vertical component is solely downward, or vertical component is there. The downward vertical component applied on this vessel because as liquid press the wall, that's a wall down, and then the force on the liquid is in upward, right? That's all. You can see here that's a equal and opposite reaction apply on it, right? So now I can write as a weight of the liquid inside this. I'm writing there. That's a mg, the weight of the liquid inside the vessel. Now the mg is greater than this F1. Right. Previous case it's F1 and mg are equal. Now it's greater because A is rho G, this is the mg, this is the weight, the previous weight. Now a little more liquids are there. Okay. So then the resultant of these two, right? So that is the force experience on these surfaces, the curved faces of the vessel. Because to balance the that there's a total force acted on the total force exerted by the liquid that should be equal to the weight of the liquid inside it. So it cannot get any force greater than the total weight. Okay, then you can write that's a force on curved faces or the wall of the containers. So that's I'm considering that's if wall, yes, we can write in that's mg minus F1. If you know the volume of the liquid inside and multiplied by the density, you can find the mg. And minus F1 is H project. So that's how we can find the force on these walls. And in this case, here the force is applied upward. Applied perpendicular to the wall in this, and its component is then upward. Right? I'm drawing the walls like this. upward force, and the horizontal component is used there, but horizontal components are cancelled out. It's used with upward. Oh, hello. Sorry that there was some disconnection. Okay, signal loss එකක් වුණා එකපාර. So, අර ලියාගත්තද අර ලියාගන්න TV ලියාගන්න පුළුවන් වුණාද නැත්නම් මොකද මේ කරේ? කනෙක්ෂන් ලොස් වුණා මේ. පේජ් එක නැකේනවා. ලියාගන්න බැරුණා නම් කියන්නේ මොකද ඔයගොල්ලෝ නිදා ඔක ක්ලාස් එකේ මම ඇඳලා ආවේ. මොනම් මම ආයෙ අඳින්නම්. අනේ ඩෝලේ නැද්ද කියලා කියන්න බලන්න. Alright. මොකෝ කරලා මේ යන දරයි කියන්නේ. right. මෙහෙම වෙසිස් ටික දුන්නේ. ෆස්ට් එක ආයෙ නිකන් ඉඳගන්න බැරලා නම් ඔයගොල්ලෝ නගන්න. අත්තාල ආයෙ කියලා දාන්න. දැන් ලික්විඩ් එක තියෙන්නේ height එකද. So that's from surface area A, that's height is h then. The forces acted on the side walls are equal and opposite, so they cancel. There are no horizontal force. Horizontal force is not there, that is zero. And the vertical downwards has a force that's experienced by the pressure. It is equals to the AH rho G, and here it's equals to weight of the liquids. So there are no horizontal force then on the horizontal walls, right? Okay. And then second one, the liquid is to the height h, let's see, and this height is h. There's liquid inside it. Liquid of is 0. And here you can see that's the same cross section area of the bottom. And then now considering dotted line representative that the vessel, the process like that. This volume is there. Now we can see this volume in this whole container is now greater than the that's the weight of the liquid hypostasis, right? So now the bottom wall has the force F1, let's say, that is similar to the previous one, that's A rho G. That's now the weight of the liquid inside it, the MG, that is greater than F1. You can see here because that side walls are inclined. So then there's more liquid inside it than this AHO, right? So it's greater than F1. So then the resultant force is the force applied on this side walls. You can see here on these walls, forces acted on the walls perpendicular. And the component of these forces in horizontally, so they're equal and opposite, they come and they cancel. But the forces, the component of forces acted vertically, they're having a resultant, it will not cancel them. So that resultant force equals to the this unbalanced force of this weight and the force due to the pressure. So then we can say the let's see the right force on the wall is there. I'm taking this F. This F means that all the forces, right? Total resultant force having this solved by force. We can write this equals to the weight minus force due to pressure. If you know the volume, and then you can get this mg. F1 is H rho G already. So then you can calculate this force on this side walls of the container, right? And right, this is the force on curved faces. Face on the container. So, face of the container. Basically mixing up that empty. So that's the process come this downward component and other horizontal component are cancelled out. Right? So you can get an idea always the force on the side walls or the force on those walls that's equals to the resultant of the weight and the force due to pressure. Keep in mind. I'll put example also. Okay, then I'll go to the third one. Do you have any questions you can ask? ප්‍රශ්න තියෙනවා නම් අහන්න පුළුවන් එක. හරි මම මේක. ඉතින් ලොකුවට වෙනවා මේ bottom has the same area කියලා මේ කලින් ඒවත් එක්ක compare කරන්න හින්දා the area of the bottom is same කියලා මම consider කරන්න. හරි. Right here then මේ volume එක ගත්තොත් මෙහෙම මේක පඩිය ටිකක් දානවා. මේක තමයි දැන් first ටික එකේ තියෙන විදිය විතර එක එන්නේ මේ ටික. මෙන්න මේ ප්‍රමාණික liquids the lack of the liquids there. So then the weight inside this vessel that's less than the Pierce experience on the bottom one. So it's also having the same one liquid to the same height. Density is low, then this one is the force experience on the bottom. Due to the pressure, you can write that's AH OG here. And here you can feel that's weight is less than the this F1. So if it is less than F1 means this force acted on this side was perpendicular to the wall then. Sorry. Like this. So then the resultant force acted on the body in upward. Horizontal forces will cancel. So let's say this total force acted on these walls upward is F. So then you can write F equals F1 minus mg. Is the force on south base. So its upward force will come. තමයි resultant එක හැදෙන්නේ. Fun. හරි. All right. People exam. අවලට ක්වෙස්චන් එකක් දැන් මොකද වෙලාවක් තිබ්බත් දන්නේ නැහැ බලන්න මේක ඩිස්කස් කරමු මොකද ඒ වගේ දෙයක් හයිඩ්‍රෝස්ටැටික්ස් වල මොනවා හරි ක්වෙස්චන්ස් අහන්න පුළුවන් නෑ ප්‍රශ්න නැහැ මේ කියනවා පොඩි ප්‍රශ්නයක් කරමු ක්වෙස්චන් එකක් කරමු මම මේක පොඩි ඩ්‍රොයින් එකක් තියෙනවා it's a vessel like this right පොඩි ඇතුලේ ඒවා ගණන් ගන්න එපා හරි දැන් මේකේ තියෙනවා this liquid let's see up to this point this filled with liquid right මේක ඉඳගෙන දැන් මම තියෙන height එක okay density of this liquid that is water here in given මොකක් හරි අද කනෙක්ෂන් එක නැති වෙනවා ඇති වෙනවා නැති වෙනවා. දවල් එහෙම තිබ්බේ මේ දවල්ත් මම ක්ලාස් එක කරා නම මොකක් හරි එකක් හරි ගණන් ගන්න එපා එනවා යනවා පොඩ්ඩකින් හරිය සමහර විට දැස්සේ ඉඳ වෙන්නත් පුළුවන් බලමු හරි ප්‍රශ්නේ තියෙන්නේ මේකේ ඩිස්කනෙක්ට් වුණේ ගමන් මේ හරියෙන් ඇදපු ඒවා ටික ඔක්කොම යනවා ආවුරුද්දෙන් අදින්න වෙනවා ඒක හරි ඉස්සෙල්ලාම මම ඇන්දේ ඒක දැක්කනේ මම දැන් ඒක ආයේ කටුවකට අදින්නම් ඕනේ ඊළඟට කපන්න යන්නේ කොල්ල මයික් අන්දින්නකො මේක මම ඊට පස්සේ ක්වෙස්චන් එක දෙන්නම් that's the liquids the density inside this liquid, let's say it is a 1,000 kilograms per cubic meter. So then this height is a volume of liquid inside this total volume of the liquid inside this vessel, right? So we'll take it as the volume. Roughly the volume of all the liquid inside it, that is 2.5 into 10 to the minus 3 cubic meters. And 2.5 into 10 to the minus 3, that's all liquid inside the vessel. Volume of the liquid inside it is 2.5 into 10 to the minus 3 cubic meters. And density, sorry, and this height, taken is as 25 centimeters. Right. Then you can find the force acted on this side. That's acted on side as curved surfaces. Fine. Another thing I forget to give, that's the area of this bottom base also you need, right? Area I'm given you that 40. 40 million. I'll give this as 0.12 square meter, right? Area of the bottom of the vessel is this much, so then you can find the forces acted on the side walls or the curved faces by the liquid inside it. You can find the total force acted on the curved faces due to the liquid. Hi. රටට උත්තරයක් තියෙනවා නම් කියන්න තමයි හොඳයි. නෑ නේ මම හදන්නේ. නයනවනේ අපරාධෙන්නේ. Right. Here you can write it as I mentioned before. This force on this bottom wall and the weight of the liquid also. Writing this weight of the liquid inside is you can write as a volume multiplied by density into G. So the volume is then given as 4.5 into 10 to the minus 3 cubic meters. Rho is 1000 and G is 10. So you can write here. So that is 25 Newton. The weight of the liquid inside is this. That's force experienced by the pressure on the bottom wall. That's a H rho G. A is the area of the bottom surface, right? For this area, you can write 0.12. H is 25 centimeters, 0.25 centimeter, 2 pi meter. Rho is 1000 and G is 10. So it's gives you the value like that. 12, and this is 12 into 25. So 1, 2, 4, 6, 7, 8, 25. Okay. Leave area. Post දෙකේ සාල්ටන් ඩිෆරන්ස් එක තමයි වෝල්ස් වලට එන ෆෝස් එක වෙන්නේ. නේද මේ තියසල තමයි දෙන්නවා. After simplifying this, show This is 0.12 multiplied by 0.25 multiplied by. And this will be 300, right? Then the force on these walls, let's say it's F, you can write then F1 minus F2 because mg, so that's greater than 300 minus 25 is 275. Yeah, then walls something. So do the wall like a fix බව දෙක නැහැ නේ කියන්නේ. ඇලවෙච්ච එකක් නැති හින්දා ඒකට ඉන්නේ ඔය පහළ තියෙන වෝල් එකෙන් තමයි ඔය පෝස් එක ඔක්කොම යන්නේ. හරිද මම අර ඉස්සල්ලා ඇප්ලයි කරපුවා. මේක හරියක් පොඩ එහෙම වෙනස් නම් අපේ විදිහට ඔක 20 කීයක දේ ලෙවල් වලට ඔය වලින් ගන්න. හරි නේද? ඔක්ක තේරෙන්නේ නැති කෙනෙක් කොටස තිබ්බොත් කියන්නේ මම ආයි කියන්නේ. හරි නේද? මම next. මම දැන් බෙන්නෝ කියනවා මම. ඒක දානවා. Then let's discuss about the equilibrium of submersible. Equilibrium of submerged body. හිතමු එහෙම. As a liquid below this line. The liquid is below this, right? So then I have object. I'm considering object in this object. My God, I'm considering, right? Color लगाना. So this is the object, right? Considering like that. Now, let's say there are some heavy part, right? Heavy section of this body. In this part is much heavy. So then you can see, you know that also the center of gravity of this system is not at the middle now because this is heavy and the center of gravity is not the middle, it's on the top. Center of gravity is this, so then weight is acted on this one, right? And but the body is fully immersed, so center of gravity is at the middle. So the upthrust is acted on this point, right? Now let's say if you tilt this object little bit, this called Mokoden. So what's happened? This pass is much heavy. So center of gravity, that's a weight experience of this point, and the center of gravity is upward. Move upward, right? Sorry about this. Diagrams are not clear. B means that's the center of gravity are used. You can use H also, and this is upthrust. Now we can see here this weight of the body and the upthrust this makes um, the moment to this direction, right? So when the body is tilted to this side, it automatically then that's a restoring force acted on it to bring it body to its original position. So that's we call it stable. So here it's stable. Why it's stable? Because the center of gravity is below the center of gravity. So that's the other way around. මේක දැන් ලියන්න දෙන්නේ මේක අඳවන්න පුතාව වගේ. The other way around means this heavy part is above and like this. Right? Nothing but the center of gravity is somewhere here. There's a weight එක වැඩි උඩන තියෙන්නේ. මේ පාට කරලා තියෙන්නේ ටිකක් බර වැඩි. Of gravity is here. The center of gravity is at the middle because it's fully immersed. Upthrust is acted on this point, that's upward. Weight is acted on this point. And here also, if you tilt this body a little bit, what's happened due to the moment set on it, it will never come to this shape. Now this weight gives the moment to this side, and the normal action also gives the moment to other side. Then I throw moment again, maybe back. So it's called unstable. Neutral එකේ result එකක් තියෙන එකම තැනමයි දෙකම තියෙන්නේ. That's no matter we need to. ඔක නිකන් ඇදගන්න තියාගන්න හරි. You need to consider that for a stable equilibrium, the center of gravity should be below the center of buoyancy. And if it's unstable, it's equilibrium. So on the way, the vice versa, right? ඇදගන්න ඇදගෙන ඉවර නම් කියන්නේ. හරිද? ගොඩක් රැම නිකන් කරන්නේ මම. දෙන්න හොත්තනවා. තව පොඩි කොටසක් තියෙන මේ ටික කරන අවස්ථාව. ඒකට මේ පාර එන්නේ ඉතින් ඊළඟ දාලේ වෙනුනේ කරනවා. හයිඩ්‍රෝස්ටැටික් වාතය. ඒක පොඩ්ඩක් ටික කරනවා. Fine, I'll change the page. First, you need to keep this mind as stable nucleus. I'm writing there. That's the center of gravity. Center of gravity is below the center of gravity. And here, stable on the center of gravity is above the center of right above the center of gravity. So it's unstable. ඔය MCQs වලදී ගොඩක් අරවයි. හරි. Right, that's accelerating of fluid. Consider under the accelerating phase, you can write first acceleration of the weight vessel, the liquid vessel. Yeah, the acceleration of a liquid in vertical direction. Acceleration of liquid in vertical direction. Only when the fluid vessel is accelerated, it's there's a hydrostatic pressure applied on the point, the liquid will be changed. It will not be constant value. So let's see how we change it. Now we have another. We have accelerated and this liquid this vessel accelerate with acceleration A. So then the pressure, the force applied on this top face of this body, yes, you can write that's the pressure on the top face multiplied by the same. And down face also you can write that's the bottom face. This P2. This P2A is the force experience on this body, and its weight is also downward the same G. So then you can apply the equal MA P2A minus that's mg minus P1. That's because of massive acceleration. That's up to for this body. I'm applying this equal, right? Then body again now. then you can write this is P2 minus P1. Okay. That's will be taken to the side M G plus. So this M you can write A H. So G plus. Here this AH rho, that's G plus. That is equal to P2 minus P1. And so A cancel. That P2 minus P1. That's equal to the pressure difference of top and bottom phase of the liquid. Of the body immersed in liquid, that can be P2 minus P1. That's you can write it rho P plus. This is the pressure inside. So there's a difference between these 2 points, right? Now, based on this, you can think something. If the vessel is falling down with the acceleration of gravity, so then the P2 minus P1 equals two minus P1, that's equals to H. So that's G. It's also going down now. It's minus G. Then minus G can any පල්ලෙහාට ගන්න. ඒකට එන පල්ලෙහාට minus G. G and G. So then it's 0. It's mean to that so P1 minus P2. The P2 minus P1, that's P2 equal to P1. Here, this is 0. So then there's no pressure. These 2 points. Can we liquid actually the every point they're having the same pressure. So no change in pressure because of the acceleration of gravity. It's called free falling. In the body is free falling. There's no hydrostatic pressure inside. And the similar results apply in the upthrust also. Upthrust, when the body is moving upthrust also we can write as that's V rho, that's Z of G, that's effective acceleration, that's G. But actually when it's moving up, it's G minus E. So G plus A because of the upward is motion, right? G plus A. When it's going down, only hard. No, either horizontally or gap. You can write the equation for the pressure difference. හරිනේ රාත් වෙනවා. මේකේ මං කියන්නේ. This is mean that's free falling. When a liquid vessel is free falling, inside the liquid, every point has the same pressure. So it's equals to here P1. P2 minus P1 means when you consider about this, that is atmospheric pressure. So it's the points on the liquids the atmospheric pressure when the body is free falling. Like I similarly have applied on the upthrust. Fine. Now the second one is accelerating vertical, it's horizontal. Simulation. Liquid vessel. Acceleration තමයි අපි කියමු horizontal acceleration කියලා යනවා. Horizontal acceleration of the liquid vessel or liquid content. එහෙනම් යාගෙන මම කොහොමද යන්නේ අමාරුයි. Horizontal acceleration of a liquid content. It's a liquid vessel. Then it has a liquid there's no motion. It's no motion. So the liquid is this type. When it accelerates, you can see here. Because of inertia of the particles, then its particles move backwardly. Means and over Mama and Ganami, but I make this that this angle is theta and the height difference is h. We can apply figure MA this direction. Then up in the on the particles, particle on the surface. I'm making all the reaction of because of this pressure. Every atom second interact with the component this is theta, and this one. Then this is R cos theta. And another component is the R sin. And when we point එක කරලා මේක මෙහෙම accelerate කරනවා මේ R sin theta component එකට neighboring atom එකෙන් දෙන reaction එකේ ඉඳලා මෙයා මෙහෙට යන්නේ. Right. So මේකේ මේ පැත්තට දැම්මොත් R sin theta that's equals to the upward case. The upward forces the R cos theta that's equal to weight. Dividing these two, you can write that tan theta is equals to AOG. So if it hold this angle, let's say this angle in geometry, you can figure that tan theta you can write as it's divided by. This length of the vessel, let's take as L. So it's similarly that's the so then the acceleration of the vessel is right, that's GH divided by L. Okay, in this acceleration, if you can find this amount of the liquid level change, that's IH, and the length of the vessel, then you can calculate this acceleration. This is you can use as a accelerometer. Right. Right. Can liquid accelerate accelerate then okay then decelerate no acceleration is greater than zero. At least decelerate. You may better. හරිනේද? හරි මේ හයිඩ්‍රෝමීටර් කියන පොඩි පොයින්ට් එකක් තියෙන එක කියලා මම නම් කරනවා. හරි. බලන්න අන්තිමට තියෙන දෙක. හයිඩ්‍රෝමීටර් කියන්නේ hydrometer. That's a basic instrument which can measure used to measure the density of a liquid. Problem is here that's for the large amount of liquid is required because this hydrometer should be immersed on and plotting principle is used to get the density. But we don't need to do any calculation. That's the system indicating the scale. Okay, under that was right there. Hydrometer is the hydrometer is a basic instrument. Is a basic instrument which used to measure the density of a liquid. Used to measure the density of a liquid. Right, the plotting principle. Sorry, it's work under the plotting principle. It works under the plotting principle. And the volume is again one may up on the area. Bala item है यार Kira may kasama ni may wrestler ka kira may theater ये ठीक है then आगे का हर किसी तो मोने see that spider says as in a liquid then पानी आता है liquid I'm considering here to write this principle. Mechanical that's calibrated scale is consider as volume of the container below this point is V naught. So the weight is applied on it and overreact, sorry, an upthrust. I'm drawing this upthrust sector and for floating. You can see this upthrust equals weight. Upthrust you can write as the V naught, this cross sectional area of this part of considered in the A and the then immersed in the liquid considered as L. So this initial volume is V naught plus this systemic volume again A. Right. This is a volume U, this VOG, it's mg. You can write the density equals mass divided by resume, right? Now, according to this, you can see the higher the dense, this height of immerse is less because rho and it has the inverse relation there. Then because of this, you can see the hydrometer is more immersed in low dense liquid. So rho is proportional. Directly proportional in the higher the density, though this is lower. That means ලොකු density නෙවෙයි ගිරෙන්නේ අමාරුයි. ගිරෙන්නේ වැටලි පෙරලෙනවා ගොඩක් වෙලාවට. ඕගොල්ලෝ ලියාගන්න බැරි වුණාද? මොකද මේකෙම නවත්තන මේ කනෙක්ෂන් එකක් හරියට ස්ටේබල් නෑ. ලියාගන්න බැරි නේද මේ ඉක්වේෂන් එක ආයේ ලියන්නද නැත්නම් ඕගොල්ලන්ට බං කියන්න පොතේ. ආයෙ ලියුවේ ගවලන්න. අර ඕපේ නම් අපේ එන්නේ මේකේ මට මේක නම් කරන්න බැරිද මම. නිකන් heavy object එකක් තමයි මේ හරි දෙනවා නේද? සාමාන්‍යයෙන් dead shots හරි ඉතින් පොඩි wax layer එකක් දාලා දෙන්නේ මේවා එහා යන්නේ කියලා වළක්වන්න. මම ඉතින් ඒකට මේ මම අර මෙයාලෙන් දෙනවායි L කියලා ගත්තා. මේ වොලියුම් එක කියන්නේ මෙන්න මෙතන ඉඳන් පල්ලෙහාට දෙන වොලියුම් total volume එක වෙයි. Right. Weight of this is mg plus F1 is 0. මේ cross section area එක ගන්න වෙන මේ චූරි. මේ තමයි මම තිබ්බේ මේකෙන් liquid of density order. So when it's plotting, you can write that mg equals u density. So that's mg, that's u equals that's v naught, the volume of this bulb plus the volume of this stem. That's cross section area multiplied by the area. It is v. The rho. So you can write m over v naught plus v. After that, you can write there. That's the inverse relation. That's inverse relation between the pressure and the between the density and the L. L you can see here in the. So according to this, we can say then this hydrometer more immersed mass in load. Low density. Hi, okay. Terima kasih. Itu juga pina juga. There any question you can ask? I will give some question. Demang orang question dekar demi ikat kerang ini lah sekolah dia. Man discuss kerang sekolah discuss करने का मैं order. මේ හයිඩ්‍රෝමීටර් එකේ තියෙන එක ස්පෙෂලි ඒස තමයි එක එක රේන්ජස් වල දැන් ඩෙන්සිටිස් වයින්ද එක එක හයිඩ්‍රෝමීටර්ස් තියෙනවා. ඒක මේ බාර වෙනස් කරලා මේක මෙතන මේ හයිඩ්‍රෝමීටර් පල්ලෙහා තියෙන්නේ more heavy weight එකක්. ඒක කරලා තියෙන්නේ center of gravity පුළුවන් තරම් පල්ලෙහාට අරන් තියෙනවා center of buoyancy වලට වඩා පල්ලෙහාට. ඒතකොට center of buoyancy උඩින් තියෙන නිසා so it's more unstable equilibrium එකට ගන්න දෙසි. වැටෙන්නේ පෙරලෙන්නේ නැතුව තියන්න පුළුවන්. එහෙම නැත්නම් අපිට එහෙම ලොකු බාරක් දෙන්නේ නැත්නම් essential topple වෙනවා නම් හැමතිස්සෙම stable form එකට එන්න. හරි එළියාගෙන ඉවර නම් then stop. Good night for leave වෙන ඉවර නම් ප්‍රශ්න තියෙනවා නම් මොනවද අහන්න. මම ඉතින් ටික ඉනාගසි කරන්න. මේ කනෙක්ෂන් එක ස්ටේබල් නැති ඉඳලා ටිකක් අමාරු නෑ. Okay, good night. God bless.
Thank you, sir. Good night, sir.
Okay, good night. Good night.